మామూలే. If a monochromatic light is allowed to fall normally onto this plane convex lens and plane glass plate arrangement, the reflected light when observed through a travelling microscope will consist of circular bright and alternate circular bright and dark fringes with a dark ring at its point of contact. So these rings are called as Newton's rings, and these rings are formed due to interference pattern between the two waves which we have divided along its amplitude. When the air film is illuminated by monochromatic light, the observed interference fringes are circular concentric rings of alternate bright and dark color with a dark fringe at the point of contact. The rings are circular and has loci of points, that is, the center of all the rings is common at one point. The rings gradually become narrower as their radius increases. As we move away from the midpoint or the point of contact, the width of the rings will gradually decrease. And this can be mathematically understood as follows. Consider AB as a incident wave, which is shown in the figure with arrow marks clearly that it is coming towards the glass plates. At point B, this ray touches the denser medium and undergoes some deflection in its path. That is nothing but refraction of light takes place in the plane glass plate, plano-convex lens, and after coming out of this lens, it again moves away from the normal, since the light is travelling from denser medium to rarer medium. And here the division of light along its amplitude takes place. Here if we clearly see, the incident light is only one ray, but the reflected light rays are two. That means one single monochromatic light which we have incident on this arrangement is divided into two reflected rays. One ray is reflected at B and the other ray is reflected at C. So one is reflected from convex lens, the other is reflected from plano glass plate. So this is what it is happening, and part of the light ray will also undergo transmission into the glass plate, that is shown by CE and C1E1. So we are here, Newton's rings can be formed in two methods. Newton's rings can be formed in reflected light and also in transmitted light, but we will be discussing about the Newton's rings formed in reflected light. So a single incident ray divided into two rays by the process of division of amplitude. Now if Newton's rings are formed due to reflection of light, the brighter fringe is appeared if it satisfies the condition 2 mu t is equal to n plus half into lambda, and dark fringe or dark ring is observed if it satisfies the condition 2 mu t is equal to n lambda. Now n is order, lambda is wavelength of the light we have used, mu is refractive index of the convex air film. Here the refractive index of air film is considered. T is thickness of the air film. Radius of Newton's rings. The radius of Newton's rings can be obtained or the final equation for calculating radius of Newton's rings is given by r is equal to square root of n lambda capital R by mu. But we need to understand how this formula has been obtained. So the expression is obtained by the following procedure. Now consider the diameter of some nth ring. Usually the diameter is given by 2 times the radius, and this diameter is again, but we already know that the radius of the Newton's ring is given by square root of n lambda r by u. The difference in the two diameters to nearest dark rings is given by d2 minus d1. 2, and after having all this done, the final equation appears to be lambda is equal to d square n minus d square n plus m minus d square n divided by 4 mr, where rings by observing through the microscope can be counted. Diameter can also be taken from the position of your microscope vernier scale readings, and radius capital R, radius of curvature of the given convex lens, lambda is the wavelength of the light we have already used. So this is the procedure for calculating wavelength of given light using Newton's rings. So this is one of the application of Newton's rings. If we move towards applications of Newton's rings, Newton's rings experiment can be obtained for calculating wavelength of a given sodium light or given monochromatic light. It can also be used to determine refractive index of a liquid. For this purpose, the air film that is formed is replaced by the liquid within the set plano-convex lens and plain glass plate. In the middle we have air film. Instead of air film, if we are able to fill the gap with liquid medium, then the refractive index of that liquid medium can also be obtained using the same formula that we have derived above, as lambda is equal to d square n minus d square m plus n minus d square n divided by 4 m r. But how did we arrive? So these are the application part of Newton's rings. But how did we arrive to a point of getting the formula for r is equal to square root of n lambda r by u is an another video that would be posted just after viewing this video. Thank you.